Assalamualaikum. So we continue our lecture for part 4 in chapter 6. So in this part we're going to discuss about the Dalton's law and Graham's law. Okay, Dalton's law. According to the Dalton's law, the total pressure of a mixture of gases is just the sum of the pressure that each gas would exert if it were present alone. So P total equals to P1 plus P2 plus P3 plus P4 and etc. Okay, example, if we have air container, so dalam air container ni contain a partial pressure of oxygen, so partial pressure of nitrogen, partial pressure of argon, partial pressure of water, and partial pressure of carbon dioxide. So when we total up all these partial pressure, we get the total pressure. Okay, this picture shows the partial pressure of A, okay, partial pressure of component A and partial pressure of component B. So gas A and gas B. So when we total up the partial pressure of gas A and gas B, we get the total pressure. Okay, so 300 plus 400, we get 700 millimeter of mercury. Okay, next we look at the mole fraction. So mole fraction is one way to express the relative amount of substance in a mixture. And the mole fraction is a ratio of the number of moles of one component to the number of moles of all components present. So in general, the mole fraction of component A in a mixture is given by mole fraction of component A equals to Na. Na is referred to the number of mole of substance A divided with Na plus Nb. So Na is a number of moles of substance A plus Nb. Nb is a number of mole of substance B. Or we can write as a mole fraction equals to Na over N total. Okay, and the partial pressure can express as Pa equals to Xa Pt. Okay, so Pa is a partial pressure of gas A. Xa is a mole fraction of gas A, and Pt is a total pressure. Okay. Look at the example. A sample of natural gas contains 8.24 moles of methane, 0.421 moles of ethane, and 0.11 moles of propane. If the total pressure of the gas is 1.37 atm, what is the partial pressure of propane? So you have to calculate the partial pressure of propane. Okay, so from the equation, partial pressure equals to mole fraction times total pressure. So first we have to calculate the mole fraction of propane. Okay, so X propane equals to 0.116. Okay, so we have mole of propane is 0.116 over with total number of moles gases molecule presence. Okay, so we have 8.24 moles of methane. Okay, methane plus with 0.421 ethane, and plus with 0.116 propane. Okay, so you will get 0.0132 mole. Okay, so once you have mole value, you also have total pressure. So you just masukkan dalam formula ini. Okay, so P, partial pressure of propane, equals to 0.0132 times 1.37 atm. So you will get 0.0181 atm. Okay, alright. According to the Graham's law, there are two phenomena based on gaseous motion, namely effusion and diffusion. Okay, effusion is the process by which a gas escapes from its container through a tiny hole into an evacuated space. And diffusion is the process of gas movement of one gas through another. Okay, so if you look at the figure here, the pictures shows that differentiate between the effusion and diffusion. So kalau untuk effusion dia mesti melalui tiny hole. Di mana tiny hole ni selalunya merujuk kepada microscopic hole. Contoh for effusion ialah balloon. Okay, balloon dia contain tiny microscopic hole. So macam kita tiup balloon hari ni, after a few days balloon tu akan jadi kecil. Sebab apa jadi kecil? Because of gas particle tu dia dah escape. Okay, escape through the tiny microscopic hole via effusion process. Okay, and diffusion ni dia just separate the gas particle. Okay, contohnya you masak. Okay, if you cooking in the kitchen and then satu rumah semerbak bau apa yang you masak. Okay, so this is because of diffusion ni, dia punya particles akan bergerak daripada high concentration to the area of low concentration. Okay, so daripada dekat dapur tu, you masak, so dia akan spread out pergi ke seluruh ruang yang berada di dalam rumah. Okay. Okay. According to the Graham's law, the rate of effusion of a gas is inversely proportional to the square root of its molar mass. Okay, so kalau you lihat kat sini, rate of effusion inversely proportional to 1 over square root of its molar mass. Berkadar songsang. Rate of effusion berkadar songsang dengan punca kuasa 2 molar mass. This there are two equation here. So the first one is time A over time B equals to square root molar mass A over square root molar mass B, and rate A over rate B equals to square root molar mass B over square root molar mass A. So this both equation is generally used for comparing the rate of two different gases at equal pressure and temperature. Okay, so ini A ni refer kepada gas A lah, and B refer kepada gas B. Alright. Okay, we go to the example. Okay, at a specific temperature, helium effuses at a rate of 2.5 mole per minute. What would be the rate of methane effusion at this temperature? So here we have helium gases and methane gases. Okay, alright, so we we have to calculate the rate of methane. Kita gunakan formula rate A over rate B equals to square root molar mass B over square root molar mass A. So rate A, rate helium ialah 2.5 over with rate of methane yang kita nak cari equals to square root molar mass of methane is 16, okay, over square root molar mass of helium. Okay, so we will get the value of rate of methane is 1.2 mole per minute. Okay, alright. So that's all for part 4. Thank you.